What's going on, guys? Welcome to another problem. In this one we're going to do Leetcode number 53, maximum subarray, a very popular problem. So what's the prompt say? Given an integer array nums, find the contiguous subarray that contains at least one number which has the largest sum and return that sum. So contiguous subarray, just a subarray where elements that are next to each other or adjacent in the array. An array within an array, not like, this isn't asking something like, find k elements that make the largest amount. These numbers have to be next to each other. So in this example, -2, 1, -3, blah, 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 the largest subarray is here, 4, -1, 2, and 1, which add up to 6. Okay, so that's the largest sum you can make with a subarray in this larger array. Okay. Follow-up. If you figured out O of n, try coding another solution using the divide and conquer. Okay, so I haven't done that, so maybe we'll do that in another video, but in this one we're just going to do a simple O of n solution, which is actually fairly straightforward. Okay, so let's initialize a couple variables, and we'll walk through it step by step. So we're going to keep a running sum, create a couple mutable variables, and we'll just initially set this to 0. And, oops, come on, spacing. What's going on here? And we'll also create a largest variable, which we're going to return at the end, and we'll set that to be the first element of this array. Okay. Then we'll have a simple for loop. We'll say for I 0 until nums.length. I believe that should be right. This is in Scala, by the way. This solution can be easily translated to like any language, so this is just for fun. Okay, so now what we're going to do is update these variables. So basically what we want to do with the running, which is basically our current sum, is sort of keep track of the largest sum we can make at every index in this array. So if we have running, and let's use the math module here, and let me write it out and then we'll explain it. We can basically throw away results, which is why this is so cool. So we can say math.max between the running sum plus the current element, or just use the current element, right? So let's look at this. Running is 0. So if we do 0 plus -2, that gives us -2, and our current element is -2, so what's larger? Well, this doesn't really make sense because those are the same, so that stays the same. But once we get to 1, okay, our next index, at the first index, we're going to have a running sum of -2, but our nums I is 1. So what's the largest sum here? We can basically restart now, and we're starting at 1 because that's larger. This item on its own, 1, which is the first index, is bigger than summing running, which is -2, plus nums I, which is 1, because that's -2 plus 1, that gives us -1. So what's larger there? Obviously just 1, right? So we can proceed that way. So let's move forward. Now running is 1, and our current element we're on is -3. So -3, what's larger, -3 or -2? Well, -2 is larger, right? So we've actually added these two. We've used this variation right here, running plus nums I, because that gave us -2, as opposed to just keeping -3. Right, because -2 is bigger than -3. And we're going to continue doing that as we iterate through our input array. What we can then do here, though, is just keep track of what the largest is. So again, we can use math.max and figure out if the largest, which we start at -2, the first index, say largest, or our current running sum. Okay? And then we'll just go ahead and return largest. So let's run this and see if this works. It's an implicit return, so this should work. Come on. There we go. Okay. Actually, does this? I think this should work as well. Whoops. Too fast. Cool. Okay. So hopefully you can see how that works. This is a really fun problem. I actually just realized we can do something better here and start this at, I don't know if this is better, but start this at nums 0. I starts at 1. That way we're not sort of wasting that first iteration, and we'll just start our running sum to be the first item as well. And let's see if this works. Okay, cool. So to recap, we're basically going through this array, finding what the largest sum at basically each index that we can make is, finding what that is, by either taking the current element or taking the sum that we currently have plus the current element, okay? And if the current element makes a bigger sum than using all the other ones before that, then we can just start from there. We don't need to use the ones before that, okay? And then we find just the largest by computing what the current biggest is, or the running sum, and then we return that. Okay, so go ahead and run this through on your own. If you have any issues, maybe do it on paper with like a small subarray, maybe like a subsection of this, and let me know how that goes. There's a name for this algorithm. I'm gonna post it in the description, and you can do some research into it, but it's really fun. And yeah, let me know if you guys have any questions, and thanks for watching. Bye.